Hi everyone. This is Rakshit from Saveetha Engineering College. I am very glad to present my topic. My project title is How I Can Guard a AI powered driver vigilance system using deep learning. I have done my project under the guidance of Mrs. Dr. Anita Julian, Professor of Saveetha Engineering College, Department of CSE. This is my agenda of my project, starting from introduction, followed by statement of a problem. My statement of a problem is to develop a drowsiness detection system. My scope of the project and the methodology. In that methodology, architecture diagram, algorithm use, design, implementation, important code segments have been included. And fifth part is output and results, then followed by conclusion, future work, and references. Introduction, basically the driver drowsing detection system (DDDS) is an essential technology aimed enhancing and road safety by identifying and alerting drivers who are at the risk of falling asleep. While operating a vehicle, basically if drivers feel like drowsy, in that the driver drowsing system works and find a drowsiness. This project proposes an approach to DDDS using state-of-an-art deep learning techniques, specifically the you only look once YOLO object detection framework implemented with the PyTorch library. The proposed system leverages the power of YOLO, a real-time object detection algorithm for precise detection and tracking of facial landmarks and eye region. A PyTorch, a popular deep learning framework, is employed for model development and training. The statement of my problem is to develop a drowsiness detection system. For developing a drowsiness system, we have to develop an efficient and accurate drowsiness detection system that can monitor driver's facial features and eye movements in real time, thereby minimizing the risk of accidents caused by drowsiness driving. Extensive method for drowsiness detection may be time consuming, labor intensive, and requires specialized knowledge, posing challenges for research constraints. The proposed system integrates state-of-the-art deep learning techniques, particularly using the significantly improved disease detection accuracy. The system uses the YOLO algorithm for intensive picture analysis, overcoming the drawback of period systems, including poor precision and lengthy processing times. My purpose of the project is to create the accidents for driver caused by drowsiness. For creating a system, we have to create an automated system for identification of drowsiness, and also we have to design a system to detect driver drowsiness by continuously monitoring retina of an eye, mouth, and face, and also improving the system by working in spite of driver by wearing spectacles and in various lighting conditions, alerting the driver on the detection of drowsiness by using buzzer alarm. System of vehicles has been edited by this system. This is my methodology of my project, starting from data collection, the input, video, and face detection, and then followed by data of the processing, feature extraction, and model selection. We have to select which just the model has been, the data has been included, whether eye state or edge state and mouth state. In that eye state, they are eye closure and blinking rate. In edge state, they are head posing angle. In a mouth state, the mouth opening and closure. Then the model training, classification, and the fifth is drowsy. We have to evaluate whether the given data provides a driver whether feels drowsy or not. If yes, it busts the alarm. Methodology, in the methodology, first is eye aspect ratio. According to Rosberg, a detecting blinking using the EAR feature has multiple advantages compared to detection with the traditional image pre-processing methods. In traditional methods, first eye localization is applied, then thresholding is used to find the whites of the eye in the image. Following that, eye blinking is indicated by detecting the disappearance of eye whites region. In constraint, no image processing is needed when using the eye metric. This using it will require less memory space and a processing time. The AR metric computes a ratio extracted from the horizontal and vertical distances of the six eye landmark coordinates. These coordinates are numbered from the left hand corner starting from P1 and revolving clockwise to P6 im. Case of open eyes, the AR value remains approximately constant. However, if the eyes were closed, the distance between the coordinates P3 and P5 and P2 and P6 demolishes. Thus, the EA value drops down to 0. Order to extract the EAR feature to compute the EAR ratio value, the numerator calculates the distance between the vertical landmarks, while the denominator calculates the distance between the horizontal landmarks and multiplies it by 2 to balance it in nominator. This is my formula of EAR. The formula is equal to whole modulo by submodulo P2 minus P6 close submodulo plus open submodulo P3 minus P5 close submodulo close by whole modulo divided by 2 whole modulo P1 minus P4 the close modulo. And this is my eye blinking frequency. If ER value 0, then also it will hold whether the eye is closed over 2 seconds because we have blink the eyes regularly. If the driver's eyes were closed for more than 2 seconds, it busts the algorithm alarm. So the methodology for MAR is similar to a EAR. The mouth aspect ratio or MAR is used to calculate the openness degree of the mouth. In this spatial landmark, the mouth is categorized by 20 coordinates as shown. Using these coordinates, the distance between the top lip and the bottom lip is calculated using to determine whether the mouth is open or not. The numerator calculates the distance between the vertical coordinates. The denominator calculates the distance between the horizontal coordinates. So similar to the denominator is multiplied by 2 to balance with the denominator. Increasing the value of MAR, the mouth is open. So the formula of MAR is submodulo P2 minus P8 plus submodulo P3 minus P7 close modulo plus submodulo P4 minus P6 close submodulo whole divided by 2 whole modulo P1 minus P5 close whole modulo. So the third methodology is head postage. So head postage estimation was achieved by finding the rotation angle of an head. The rotation angle can be defined as the amount of rotation of an object around a fixed point referred to as the point of rotation. To find the rotation of the head, first the center Nose landmark was acquired by media by phase mesh for use and reference and as the point of rotation for the head position in this frame. So as mentioned as earlier in pre-processing, the nose X and Y landmarks were normalized by multiplying them with the framework with an height respectively. So following that, by taking the initial nose theoretic coordinates as the point of rotation, the rotation angle of the X and Y are calculated and used to estimate if the head position angle is up, down, left or right based on the setup threshold. We have an estimated angle threshold as follows. So basically, head post is up if the excess of angle is 7 degree. So same to a down if angle is minus 7 degree. Right means plus 7 degree right position, and left means minus 7 degree left position. So this is my architectural diagram. Starting from camera, it captures our image and frames it as 2G image frame. Then it calculates the facial features in an image, and it's categorized into eye state, head state, and mouth state, and followed by eye location, eye open, and eye close, and iris location. For head pose, it calculates the face location and nose location, mouth state. It calculates the mouth location and mouth open or close, and then it branches into submodulo like eye aspect ratio, eye blinking frequency, eye blinking duration, eyelid distance, because head rotate left or right, head lift up and down, mouth aspect ratio, mouth height. So last it finds the facial pattern property parsing. It matches the that pattern, it busts the algorithm. So this is my class diagram. So basically, a class diagram is a picture for describing a generic description of a possible system. Class diagram or alternative representative of objective model. So the models my project is eye aspect ratio, mouth aspect ratio, head pose angle. For detection, I use the condition for AR is equal to 0. MAR should be greater than 0. Head posing not equal to 90 degree. So webcam is like setup, loading, start, and facial image pre-processing. For alarm, I use two main concepts: alarm and reset for using it again. So use case diagram is simple. Like use case diagram is a type of a unified modeling language. UML diagram is used to visually represent the interaction between the users and a system, showcasing the various users can interact with the system. So starting from users, starting the camera, real-time detecting of driver, it pre-processing to facial pre-processing, captures and produces the eye aspect ratio, mouth aspect ratio, head pose angle, and finds whether the driver fails drowsy at detection and busts the alarm. So my algorithm used there is YOLO. YOLO stands for you only look what one is the state of the art. Object detection algorithm that divides an image into a grid system and predicts the bounding boxes and class probability of an object within each grade of cell with many versions as shown in the figure 2. YOLO renowned for its speed and accuracy standards and preferred option for real-time object detection application. YOLO V5 is a particularly operates to a systematic grid division of the image within the each grid cell. YOLO V5 predicts the most bounding boxes and class probabilities for object contained with the cell. So this is my layer of the YOLO, contains 7 layer, and implementation of my project is YOLO integration for real-time object detection is to detect and localize the facial landmarks including eyes, mouth in a real-time video streams. YOLO ability to pre-process a frame efficiently enables continuous monitoring of facial features of a driver, crucial for detecting drowsiness. So the CNN architecture for future extraction is to design and implement a conventional neural network architecture to extract high-level features from facial images captured by YOLO. Utilize CNN capability in image classification to identify patterns related to drowsiness. such as eye closure ratio, mouth closure ratio, and head pose angle. So the biological factor thresholding is an established to critical threshold for EAR and MAR. At post angle classed based on physical studies and empirical data define these thresholds as indicator of drowsiness, and when the observed values exceeds these threshold trigger the alert system to warn the drivers. So the real-time alert system integrates is to develop an alert system capable of providing a timely warning to the driver when drowsiness is detected, utilizing audio and visual cues within the vehicle to alert the driver, ensuring the prompt intervention to prevent the accidents. So, evaluation and optimization conduct intensive testing and evaluation of implemented system using diverse datasets containing variation in lighting conditions, driver demographics, and driver scenarios. Optimize the system performance by fine-tuning model parameters, enhancing a training data quality, and defining alert mechanism to minimize the false positives and negatives. By implementing these key points, the driver drowsy intelligence system can be effectively utilized YOLO and CNN technology to monitor the critical biology factors and provide real-time alerts, contributing to enhance road safety and reduce the accidents caused by drowsiness driving. So this is my system requirements. The basically hardware requirements is a pre-processed CPU Intel Pentium dual core and higher. So for hard disk capacity, 512 MB space required is minimum. For RAM, 4 GB is a minimum thing. Software requirements is programming language should be a Python. Observed operating system is Windows 8.1 or above. ID should be Jupyter Python version 3.x. So this is my code implementation. So first of all, I'm installing the dependencies for using PyTorch, and then I am importing a libraries and modules. Import tasks from matplotlib and pyplot, numpy, and CV2. So this is my real-time detection code, and these are my training model code to train my models. This also a model for different methodology I mentioned earlier. So loading custom models has also been initialized for model and images in order to gain the results. So extracting the output models in order to render and sequence the picture whether the drowsiness is detected or not. This is my accuracy of both the model YOLO and CNN. For YOLO, it has been shown more greater opportunities. So this is my output whether the driver felt drowsy or not. And what can be accuracy is high accuracy in detecting the drowsiness, finding best model for calculations, accurate the model classification, working in any environment and lightning conditions, increasing robustness by reducing the power consumption caused by the CNN model. So conclusion is the driver drowsiness system is actually found to present a robust solution for early detection of drowsiness, for offering a significant benefits to driver to reduce the accidents in my morning. By leveraging the advanced deep learning techniques and image classification algorithm, the system facilitates the timely identification of driver attributes. YOLO, with its real-time capabilities and accuracy in detecting specific objects, is the best deep learning algorithm for the driver drowsy detection system. YOLO-based driver drowsy system have a potential levelized road safety by preventing accidents caused by drowsy driver. For future research, I would like to have an available with more and more data and try to make our models even more accurate by training more much data. Also adding that the linking this result to a website in which the drivers are monitored, and also allowing that the decide people to trigger algorithm to make the driver through website. These websites are authenticated and can be used by certain people related to driver. We will also be storing the detection records of the driver in order to predict the driver has any clinical disorder. These records can be encrypted in order to maintain a authentication and integrity. This is my reference of my project. I have been referred and guided through these references. So the code for the whole project is here. So look at this, the code is full of Python code, initializing my dependencies, creating a file path, and keeping the color whether the eye should be white or not, keeping its accuracy higher and higher in order to maintain our integrity. And we have to run and contain with the many test cases in order to get a very accurate results. Overall, these code help us to give a very accurate model for driver drowsing system. Thank you.